Hey, hello everyone. So in this video, we'll take a look at central moments. Now, moments about the mean. Moments about the mean are also called as central moments. Okay, so these are different from two other types of moments, which are raw moments, which are about the origin or zero, and standardized moments, which involve division by the standard deviation. Okay, so these are not the topics of this video. In this video, we'll only discuss the formulae for central moments, that is the moments about the mean. Okay. Now you must have heard the term moments before. Moment is the force when you apply a force on a particular object. Okay. You must have studied this in physics. What is the amount of force generated, etc. What is the momentum? What is the moment? Uh, or you can say torque, moment of inertia. All these terms you must have studied in physics. There are some similarities, some differences, but let's not get into it. That's not the topic of this video. You can explore it. Okay. So there are some interesting similarities and differences which you can explore. So right now, let's focus on central moments. So we'll focus on four central moments. The first moment, okay, the first central moment, the formula is, okay, the symbol is M1 and the formula is 1 upon n, where n is the total number of data points, summation I goes from 1 to n, xi minus x bar. So your data is xi, x bar is the mean. Okay. Now we are not squaring this difference. We are not taking any absolute value over here. Okay. So M1 is simply the sum of the positive as well as the negative differences of all the data points from the mean. So effectively, this difference will come out to be zero. Okay. That is by the definition of mean. Okay. So therefore, first moment, irrespective of whatever data you have, first moment is always zero. M1 is always zero. First central moment is always zero. Now let's talk about the second moment. Second central moment denoted by small m2. Again, this is 1 upon n. Again, there is a summation. Summation I goes from 1 to n. And xi minus x bar term is still there. But now instead of having a linear term, we square it. Okay. So does it look familiar to you? This is nothing but sigma square. That is the variance. This is the variance. Okay. And therefore you can say that the standard deviation sigma is square root of the second moment m2. Okay. So let's move on to the third moment. Okay. So the third moment now, by analogy, analogously, you might have already anticipated what the formula might be. So it is 1 upon n summation I goes from 1 to n xi minus x bar cube. Okay. So this is the third moment. And this is related to skewness. This is related to skewness. Specifically when n is large, when we have the population case. Okay. You can go to the previous videos and take a look at the formulae and find the similarity or relationship between this moment and the skewness. So similarly, for fourth moment, we have M4 equal to 1 upon n summation I goes from 1 to n xi minus x bar raised to 4. Okay. And this, if you are watching the videos in this playlist right from the first one, if you have watched all the videos, You can relate this to kurtosis. This is related to the kurtosis. Okay. So that's it. These are the formulae for the four central moments. Okay. If you have any questions, any doubts, do post them in the comments below. In the next video, we'll take a look at solved example on central moments or moments about the mean.